Okay, so this project here is just a very basic proof of concept of getting a Commodore 64 to read just one of the phototransistors in this older optomechanical mouse. Okay, here's a good view of the encoder wheel, and here's the infrared light emitting diode. Here's the phototransistor. It has two outputs, and as you spin this wheel, which would correspond to movement, in this case I think horizontally for the mouse, the output is like a square wave. And then read that as a bit being turned on or off on the Commodore 64 user port B. Next I'll show just a brief diagram of on the screen of what the basic concept of what I'm trying to achieve is. In order to get 5 volts to power the mouse, I have a 12-volt power supply. This particular unit, I think it says Radio Shack, and it was probably, if you had something like a CB radio, it puts out 12 volts DC. If you had a CB radio you wanted to put somewhere in your house, this is the sort of thing that I think would be used for that. But I ran the 12 volts to a 5 volt voltage regulator, and then I got the 5 volts to power the mouse that way. And in order to get 5 volts DC to the mouse to power the mouse so the phototransistors work, I used this, I think it's D9 to PS2 adapter. In order to run the wires, these two wires we're going to try and take data off of, or really just one of them for proof of concept, I had to make a little bit of a cut here. I melted this piece with a soldering iron and carved it out a bit with an X-Acto knife, and here is the corresponding top half. I think, from what I can tell, these things purposefully, as I would expect, are made to be very light tight, because when, for example, when this thing is out and you're trying to read it, it's these phototransistors are always like set high because they're just getting infrared light or whatever light from all over the place. So it's kind of hard to test them unless they're in here, shaded from everything, and the only light they're getting are from the two light emitting diodes. You can even see there's like a dog leg here. I think some of that's for strain relief, but I have to think some of it's also to keep the light from entering into here and messing things up. Okay, here's the board from the mouse. This here is the phototransistor that goes to the vertical scrolling mouse encoder wheel. And then I traced it to these two pins here that go to this IC, which we're kind of ignoring here. And then I have these two small wires that I can run outside of the mouse so I can connect directly to the phototransistor. Here's the experimental setup to capture the output of the phototransistors in here. The two wires, again, go to the vertical mouse phototransistor output. Each phototransistor has two outputs. Got the power supply, 12 volts, goes down to 5 volts for this regulator, it goes into the mouse, so we're giving power to the mouse, and then we're going to look at the output here on this oscilloscope. And this oscilloscope is a ICO Model 460. These are actually, you can find these on eBay and in other places. There's quite a few of them out there. I think they were sold as kits. I do not know if any were sold fully assembled. Instead of Adrian's digital basement, this is more like Chris's analog kitchen, perhaps? Okay, and just as kind of a calibration check, I got the just 5 volts going to the input, and right now it's at 0. I turn it on and it goes up to about 5 on the scale there. And if I turn the power supply off, first we see nothing, and it comes back down to 0. Okay, I've got the mouse there hooked up to the oscilloscope, one of the phototransistors, one output from one phototransistor, and that's right there, 5 volts. Now I'm going to move the mouse back and forth, and as we expect, we get some kind of square wave looking dashes, and you notice I move it faster, the pulse width decreases, you get higher frequency. I move it slower, you get a much wider pulse and a much smaller frequency. Okay, here's the test setup. I've got the mouse powered off of the 5 volts that comes off the user port and connected to the ground off the user port, and then I have the data line from port B. I took and bit 0, the bit 0 is basically this here, and so I have that hooked up to one of the phototransistors. And remember, that phototransistor goes between 0 and 5, and the Commodore 64, when it sees data from there, it expects to see either a 0 or a 5. And this is just a simple program I use to read out the value in data port B and output it to the screen. Sorry, I don't have a better screen capture device, but we're using user port B. So the first thing we have to do is make sure the data direction register, which is 56579, we want that (0). That will set all of the bits, all of those 8 ports or 8 lines on that port will be set to read as opposed to write. So we had to do that. And then, whoops, just a simple program here that reads the value that comes from 56577, which is user port B, and then it prints that value out and then just loops back. So what we should see here is the number change as the mouse moves. And remember, we're on the line that corresponds to bit 0. So it should only change from 255 to 254 and back and forth. So type in run. Now I'm going to move the mouse, and we can see we can get it to stop on 255 or 254, or we can toggle it back and forth. And I'm moving it back and forth over here. So hopefully this can be used as some sort of method to interface with other things, either a tachometer or just some, I don't know, anything really. That's ultimately what I'd like to do. Of course, what I don't know is if it can read the port fast enough to give, RPM readings in BASIC, or if I'd have to use a machine language program.